Good. So, the definition, please. Can anyone help in helping me? Can anyone help me write the definition of f prime for the function f of x negative 1 over x? It's a very good point because we looked at a quadratic function. Now we should look at the rational. Good pick. Can anyone help? How do I write? How do I write the definition? Ready. How do I start?
Is it the limit?
Excellent. Awesome. Stop. 1 second. Stop. Excellent. Yes, that is it. That's the starting point. Excellent. Then great job. Thank you.
And then, f of x.
Yes, let's write it first. F of x plus h minus f of x divided by h. Perfect. And now the next step. I copy the limit. I copy h in the denominator. What do I write at the top? Great job. What do I write in place of this? And what do I write in place of this? Now let me copy the function one more time here. Anyone, please? Can anyone identify this for this function?
Is it 1 over x plus
First of all, I have to copy the negative. Yes, you're right. 1 over x plus h. Awesome. Excellent. Yes, thank you. Then I have to copy the minus. And then what do I have to copy?
Negative 1 over x.
Since I have two negatives, I will change this into positive 1 over x. Excellent. This is it. Now we have to struggle with this. But this is it. Basically, the first step, right? Awesome. Good. We need to find the least common denominator in the numerator. This is h or h over 1. What is the least common denominator in the numerator?
X.
Careful. That's how my cheap markers are drying out. I'm waiting for my students to say something. I'm kidding. Anyone, please? The least.
Repeat the question.
Yes, we need to find the least common denominator so I can put it here.
X plus h.
Careful.
Would it just be h?
Careful.
Oh, 1 over x.
Careful. Okay. I want to add 1/2 to 1/3. What is the least common denominator?
6.
Yes,
6.
because they have nothing in common. 2 times what is 6? 3. 3 times what is 6? 2. 3 plus 2. 5, 6.
Is it x times x plus h?
Thank you very much. They have nothing in common. X plus h times what is this? Well, times x. Of course. X times what is this? Times x plus h, of course. And now let's see what we have at the top. What do we get at the top? Can anyone dictate?
Just 1.
Negative 1 times x. What do I have to write?
negative x.
Excellent. Plus 1 times x plus 1 times h. What do we expect to happen now before I look? I don't even want to look. What has to happen? If not, I cannot continue.
Is it the h's have to cancel?
All terms without h must simplify first. So there are two steps. All terms without h. All terms without h must go away. If they do not go away, I cannot proceed. After they do go away, I have to factor out h, because this h in the denominator has to simplify. So let's see. Do all terms without h simplify or cancel out?
Yes.
Yes, they do. So now I have limit as h approaches 0. The numerator is h over x times x plus h times, I'm dividing by a fraction, times 1 over h. What is the second step that if it does not happen, that I know I say, oops, I cannot continue? What has to happen now?
Now the h's have to cancel.
Absolutely, yes, we simplify the h with the h. Awesome. Now we are ready to apply the limit. Notice that the limit operator cannot go away till the very last step. If you omit the limit operator here, and you omit the limit operator here, the whole thing makes no sense. The limit of this equals the limit of this equals the limit of this equals the limit of this. If you omit the limit operator, or you forget to write it, it makes no sense. Good. Can anyone give us the limit? Let me write it one more time. Limit as h approaches 0 from 1 over x, x plus h. Now we can apply the limit. Don't be afraid to say something, please. What do you think the answer is?
Is it 1 over x squared?
Brilliant. That's all it is. As h approaches 0, 1 over x times x is 1 over x squared. So, negative 1, that's another nice way to write it. Negative 1 over x prime is 1 over x squared. Okay, we haven't answered the question though.
I have a question for
Yes?
you. What's with the h? Why did we just get rid of the h? Oh, okay, got it.
Very good. So we haven't answered the question. I don't need all this. I had to calculate it. I had no choice. I need this. That's all I'm missing. I have the 1/5. I have the negative 5, but I'm missing this. Can anyone tell us f prime of negative 5? What does it equal to?
Over 25.
Thank you very much. Now I have the answer. What is the answer? I don't know yet. Y minus 1/5 equals 1 over 25 x minus minus 5 is x plus 5. Not done, but this is what we wanted. I needed to find the instantaneous rate of change of the function given to us at x equals negative 5, which is this. Okay, now I distribute and solve for y. This times this, 1 over 25x. This times this, 1 over 5. And bring another 1 over 5. That's it. Y equals 1 over 25x. 1 apple plus 1 apple is 2 apples. What does this represent again? It's the equation of this line. The tangent line to the graph of the given function, negative 1 over x, at this point. And you can say, what's the big deal? Okay, you gave us a function and we determined this equation. So what? You're going to see that this equation can approximate the function near it. That's one application. It's not the only one. So there are a lot of applications, and that's why I'm going to torture you with this. Sorry about that. We will determine the equation of the tangent line to the graph of such and such at a point a lot in this class because it has many applications. Good. Any questions for me? Do you have any questions on what we just discussed?
So does the equation has to always be equal to the slope and the y-intercept?
Yes, yes, because it's the equation of a line. Very good question. The equation of a line has to be presented as y equals mx plus b. At some point in time, we reviewed all the forms, but this is what we want. We want to solve for y, yes. Very good question. We always solve for y. Okay, so now I'm going to make Sammy very happy. She wanted me to move on to 1.5, differentiation rules. So she said, rightfully so, move away from this. This is difficult. This is much easier. Yes, she's right. So we're going to get to this, which is much easier than that. And I know I have only about 7 minutes left, so I'm going to stop. We're not going to be able to finish 1.5 today. Good. So there are different differentiation rules, and I'm going to start with the power rule. Power rule. Here's how we differentiate x to a power. This is n. Remember my n and my m. 3 bubbles, 2 bubbles. Okay. So when we differentiate x to a power n, and she was right, she wrote in the text, she said bring down n and subtract 1 from the power. That's it. So when we had that function before that I needed to write 2 pages on, maybe 1, I'm not sure. 2 pages roughly. So we had this function. How do we determine this without doing all the hard work? So 5x squared plus 5x plus 2. Using the power rule, f prime of x, we bring down 2, subtract 1 from the power. When I bring down 2, I have to multiply that 2 by 5 and subtract 1 from the power. And when I differentiate 5x, when I differentiate x power 1, 1 minus 1 will be 0. So x disappears. So it's just plus 5. And the derivative of a constant, if you have $2 in your pocket and you don't add and you don't subtract from it, the rate of change is 0. The $2 don't become 0. The rate of change, if you don't subtract, then the rate of change of a constant is always 0. So I should not write that. I should just write this. Prime equals 0. So that's one differentiation rule. Any constant prime is 0. X alone prime is 1. 5x prime is 5. So we didn't even need a line to determine the derivative using the differentiation rules. And look here. I started on this page, and with the definition, I finished the second page to find 10x plus 5. But that's the definition. And we need to remember that the derivative is not just some function. No, it's a combination of two concepts, the difference quotient and the limit. And if the limit exists, the derivative exists. If the limit does not exist, then if the limit does not exist, then the derivative does not. Awesome. So that's the power rule. Now, I already used the rule without telling you. So if we have a function plus another function like we had here, and we differentiate, all we get is f prime of x plus g prime of x. And of course, if I have a difference, same thing, same formula. So I'm going to open the book again. And let me look quickly here so I know the page number, 154. 154. Where's my keyboard? Here's my keyboard. 154. And let's choose. Yes, I need to explain this notation is the same thing. But let's choose anything you'd like from, let's do 37. I like to do 37 and then we'll stop. Next time you choose. So we have f of x equals 4 over x minus x to 3/5. Of course, these are not very friendly functions, right? Every time the power is a fraction is not very friendly, but very doable. We're asked to find f prime of x. The other notation is the derivative of y with respect to x. It's a different notation. They mean the same thing. You either say the derivative function or the derivative of y with respect to x, meaning y is a function of x. Same thing. So I'm going to change this, although we know now, we know that 1 over x prime is 1 over x squared. We proved this the hard way. So this is one thing that I would like my students always to understand. 4 over x is the same with 4 times 1 over x. You should always decompose it in your mind like this, especially when you differentiate. So if negative 1 over x prime is 1 over x squared, 1 over x prime will be negative 1 over x squared. So these are two formulas that you should always remember and have it written down in front of you in your notebook where you write all the important information. This is very important. So when I differentiate 4 over x, I get negative 4 over x squared. Now when I differentiate this is ugly because I have x to 3/5. And by the power rule, I have to bring 3/5 in front and subtract 1 from 3/5. Let's write it as 3/5 minus 1 first. So I have 3/5. And 3/5 minus 1, remember you have the least common denominator. So 3 minus 5. So this is negative 2/5. So minus 3/5. Of course, I'm crashing here. And I'm going to write it again because it's not clear. Because I'm running over that. So f prime of x is negative 4 over x squared minus 3/5 times x to negative 2/5. So please finish 1.4 between now and Wednesday, and we still have 1.5, 6, 7, and 8 to finish before we review for test 1. So if you want to start 1.5, you can, but we need more practice. But 1.4, please finish it by